Hello grade 11s, I'm on page 37 in your textbook, exercise 3, so we still need to do our force diagram and our free body diagram, and we need to get an expression for the friction, identify the friction and get an expression for it or calculate it. Number 7 was your homework given on the 2nd, that was Thursday. Emron rolls the cricket pitch with a roller of mass 200 kilograms. The handle of the roller is at an angle of 30 degrees to the horizontal when the roller is pushed across the pitch at a constant velocity. Constant velocity means that all the forces are in equilibrium. So to symbolize the roller and the flat surface, and just to be difficult, I'm going to indicate the pushing force as an applied force to the left, and I don't know what the size of this applied force is, but I know that it is at an angle of 30 degrees. I know that the mass of the roller is 200 kilograms, so we can get the gravitational force. I think it's 1960. Let's see. So it's 200 times 9.8, 1960 newtons. Now here, because there's a pushing force, the pushing at an angle, there is a perpendicular component to this force. So the normal force will not be equal to the gravity. I wonder whether you can say whether this normal force is smaller than or larger than the gravitational force. And if it's pushed to the left, the frictional force would be a force to the right, and this frictional force would be a kinetic friction. And the constant velocity means that the kinetic friction would be equal to the applied forces parallel component, because they cancel each other out. I'm helping you there a little bit. To draw the free body diagram, we've got weight Fg, we've got applied force Fa, and it's at an angle of 30 degrees to the horizontal. There is a normal force. I don't know if it's bigger or smaller. I'm giving you the chance to say what it is. And then there is a kinetic friction. So B is a kinetic friction. Please use the information we discussed in the videos to answer number C, or try so by yourself. And the next one was number 8. Instead of pushing the roller, Emron decides to pull the roller over a pitch behind him at a constant velocity. Oh, so the roller is now pulled. And then the friction would be to the left, and it would be a kinetic friction. The mass of the roller is not changing, so the gravitational force will remain 1960 newtons. The weight of the the normal force on the roller, because we have an applied force that's got a perpendicular component, the normal force will not be equal to the weight. Will it be larger or will it be smaller? Because the thing is moving at a constant velocity, the kinetic friction will be equal to the applied forces parallel component. So just to get you in the picture with the free body diagrams, there's an applied force. We don't really know what it is, but we know it's at an angle of 30 degrees. There is a gravity, Fg, and we know what it is, 1960, and we're not sure. There is a normal force, but I'll leave it to you to say whether it's bigger or smaller than the gravitational force. And there is a kinetic friction, which is the same size as the parallel component. So this is how far I'll go with these questions, and I'll leave it to you to get the expression or the value of the friction in question 1, 2, 3, 7 and 8. Have fun, grade 11s.